Ever wondered how to make your OBS game even smarter? Or how to find that one tiny button hidden on a web page automatically? Stick around, because today we're diving into AI-powered OBS masks and supercharged G-automation, plus a couple of brain-tickling LeetCode puzzles. This is day 51 of coding every day until I hit 1K subs. Today was a mix of project work and some LeetCode challenges. Let's get into it. First up, I continued refining my Python script for YouTube uploads. The main focus today was on adding tag support, which should make it easier for people to find the videos once they're up. It's all about those little workflow improvements. I also switched gears a bit to work on a tool I'm building for generating short-form content. Today's task was to build out a meme generator component. It's for another little side project, always fun to automate content creation. I also pushed an update to one of my Python utility libraries. This one is for helping with GUI automation tasks using PyAuto GUI. The main new addition is a scroll to find feature. So for this GUI automation library, here's a quick look at how you can get it installed. You can grab the stable version from PyPI, or if you're feeling adventurous, the pre-release for the latest features. Of course, installing from source is also an option. And here's a quick start example. You can set default paths for your images, and then just call the main function with an image name. It'll look for the image on screen, and, if found, can click it for you. The main new feature in this update is the scroll to find parameter. If an image isn't immediately visible, you can tell the function to simulate page down or page up key presses to try and locate it. This is super useful for web pages or applications where content might be off-screen. I also spent some time today fleshing out the plan for a new project idea I'm really excited about. It's an interactive tool to create and refine alpha masks for OBS Studio with an AI-assisted starting point. The basic concept is to take a camera feed, optionally have an I suggest an initial mask, then allow the user to manually adjust this mask using simple control points. The finalized mask can then be sent to OBS, and crucially, the corrected mask and frame can be saved as training data to improve the AI over time. The project will be developed in phases. Phase 1 is the minimum viable product, getting the manual masking working. This means displaying a camera feed, letting the user draw a 4-point polygon, generating a mask from that, and sending it to OBS. Phase 2 will focus on training data collection. So, whenever a user creates or adjusts a mask and they're happy with it, they can hit a button to save the current camera frame and the mask itself. This builds up a dataset for training a custom AI model. In Phase 3, we'll bring in the first bit of AI. The idea is to use a pre-trained generic segmentation model, something like YOLO version 8 seg, to provide an initial mask suggestion. The user can then quickly refine this suggestion, speeding up the process. And finally, Phase 4 is about custom AI model training. Using all the data collected in Phase 2, we'll train a custom segmentation model. This model, trained on the user's specific setup and object, should provide much more accurate initial masks, making the tool even more powerful. Alright, after those project updates, I jumped into a LeetCode problem. This one is number 2359, find closest node to given two nodes. Spoiler alert, the problem asks us to find a node in a directed graph that can be reached from two given starting nodes, say node 1 and node 2. The goal is to find a meeting node such that the maximum of the distances from node 1 to this meeting node and from node 2 to this meeting node is minimized. If there are ties, we pick the node with the smallest index. My approach uses a helper function, let's call it getDistances, which performs a breadth-first search, or BFS, starting from a given node. This BFS calculates the shortest distance from the start node to all other reachable nodes in the graph. Since each node has at most one outgoing edge, the paths are straightforward to trace. Then, the main logic calls this getDistances function twice, once for node 1 and once for node 2, to get two distance arrays. It iterates through all nodes, and for each node reachable by both, it calculates the maximum of its distances from node 1 and node 2. The node that minimizes this maximum distance is our answer, with ties broken by the smallest node index. This results in order n time complexity, where n is the number of nodes, as we do two BFS traversals and one pass, and order n space for storing distances. Next up, I tackled problem 909, snakes and ladders. Another spoiler warning. In this classic game adaptation, we're given a board represented as a grid, and we need to find the minimum number of moves to get from square 1 to the last square. The tricky part is navigating the snakes and ladders, and the board numbering is meaning it snakes back and forth. For this problem, the core idea is a breadth-first search, or BFS, to find the shortest path in terms of moves. First, I defined a helper function, let's call it getCoordinates, to translate a square number into its row and column on the board, handling that tricky Bustro-Fedonic numbering system. The main part of the solution uses a queue for the BFS, storing tuples of the current square and the number of moves taken to reach it. A set prevents cycles. In each step, it explores all possible next squares from a dice roll, determines the final destination, accounting for snakes or ladders, and if that destination hasn't been visited, adds it to the queue with an incremented move count. The time complexity is roughly order n squared, where n is the board dimension, as each square is visited at most once, and space complexity is also order n squared for the queue and visited set. And that's a wrap for day 51. If you enjoyed this, or found any of it interesting, please do hit that like button, subscribe if you haven't already, and let me know your thoughts, or any cool project ideas in the comments below. And if you'd like to support the channel, you can do so over at buymeaboba.com, links in the description. Thanks for watching, and I'll see you in the next one.